Hello everyone, and welcome to today's session when I'm gonna be discussing how we integrate with another great VMware product. The product is called vRealize Network Insight, and either yourself or your team might already be using it, especially if you're managing an existing VMware estate. Now, as you can imagine, most of us have built our networks over time, and it's not like every time there's a new technology we started from scratch, burned everything, and kind of moved away to a blank sheet of paper. And because of that, we have accumulated complexity over time. So we have a big network that spans across a lot of branches, multiple data centers. We now move things to the cloud. And then there is also the wide area network to account for, that's connecting all these remote locations together. Now, there are lots of vendors out there that do great point solutions, but each of them comes with their own way to manage, monitor, and troubleshoot. And when you're trying to reactively fix an issue or proactively trying to build in more capacity management, segmentation, etc., you benefit from having a tool that allows you to see everything end to end. And this is actually network insights logic. This idea that you connect both your VMware and non-VMware products together. It talks to them via things such as SNMP, logs, APIs, NetFlow, SFlow, IPFix, even does commands via SSH. And then you'll be able to start pulling relevant information from all parts of your network, starting from the data center, then moving towards the new cloud services, and most recently into your wide area network. In this session, we're gonna focus mostly on what vRNI brings to VeloCloud SD-WAN, but remember that it can talk to all sorts of routers, switches, and other SD-WAN devices as well. On the right hand side, this is a bit of a roadmap that I don't really have much time to touch upon, but you'll be hearing more from me hopefully by December. And this is where we're looking to better integrate with Nyansa's Voyance product. So this is an AI ops product that's looking into the local area network and pulling relevant information from, switches, wireless controllers, radio servers, etc. And the idea behind this, and VMware acquiring the company, was to extend that visibility all the way to the end device from the workloads and VMs inside the data center. Now, the first thing that you will most likely notice here is the fact that we have two routes of communication between the WAN and the vRNI backend. First of all, it's a direct connectivity. So this here done via APIs. It actually allows vRNI to pull a lot of health information, QoE, runtime, configs, etc. for not only the edges but also the gateways themselves. So you see them here, gateways and edges. But then the edges themselves can also be configured to send NetFlow data. So you see this arrow pointing upwards. You have the NetFlow and also SNMP. Now let's look at the diagram and understand exactly what components vRNI needs and how they communicate together and with the broader VeloCloud infrastructure. So here we are at the whiteboard with a very simple example. We have two edges, one deployed inside the data center and one deployed at the branch. They just use normal internet links on each side, and then hanging off the internet, we first of all have the VCO that's managing the SD-WAN estate, but then also other VMware cloud components. First thing to know is that vRNI has two main components. You have the platform, which is one VM or a cluster of VMs that you actually log into, right? So this is the way that you manage vRNI in a similar fashion as the VCO for VeloCloud. Now, the platform VM itself does not collect data unless you're looking specifically at the cloud. What it does instead, it relies on different collector VMs that can be, localized in different areas of your estate. If you're a distributed environment, you might have your platform VM cluster centralized and then your collector VMs in different data centers or in different regions. And it's the collectors themselves that, first of all, reach out to different devices. So we mentioned initially that it will reach out to the VCO via HTTPS. So this is for API access. And it will also get a feed of NetFlow data. And that from the VCs themselves. This is something that you'd be required to configure either on the edge itself or inside the profile that the edge belongs to. One last thing to note here is that when you are configuring this connection, we require you to have either a super user, standard admin, or a customer support account. So you'll need to have the username and password for both together with the VCO URL. Now, in the same way that the collector VM will reach out to different VeloCloud elements to understand their health, understand what flows go through them, in the same way you can configure it to reach out to other things. I mean, parking VMware products aside, where vRNI was targeting things such as the NSX part or VMware on AWS, you can then make it talk to normal routers and firewalls. And again, this is through standard protocols such as SSH, SNMP, HTTPS, etc. One of the questions that you might have asked yourself is, why do I have two different platform VMs in this picture? And this is because vRNI comes in two different forms. The on-premise version, which means that you will host all the components in your own on-premise data centers, or the cloud version, right? So this is where VMware will actually host the platform VM, and you will still need to deploy collectors VMs across your estate. So very important, if you go fully for the vRNI cloud version, you still have the collectors to account for. One of the interesting things of having vRNI cloud, not just because of the simplicity of a SaaS product, is the fact that the platform VM acts as a collector when it queries other clouds, right? So you not have to go on-premise to the collector and then from on-premise out to AWS. The platform VM will act as a collector for those IaaS services. Also, from a security point of view, the platform VM talks to the collector via HTTPS. So just a simple opening of 443 will actually allow it to migrate to the cloud. And then the collector itself on premise will then use loads of varied ports, which might be difficult to open up to the internet. One last thing to note here, you have this idea of VMware Cloud, which you can make communicate with your platform and collector VMs. And the reason you'd like to do that is either to register, upgrade, or get support for the products. So who actually benefits from vRNI? Well, the answer is a lot of people. You can talk to the network admin because what they're interested in is to understand the health of the underlays, the overlays, and have an easy tool that works across multiple vendors that allow them to troubleshoot and optimize. And then you have the infrastructure or the cloud admin. They'll be more interested in kind of discovering applications and having that capability to migrate and then secure them. And then the security admin itself will be very interested in the security planning, micro-segmentation capabilities, and also all the audit and compliance tools. So if you're doing anything regarding PCI, for example, vRNI can help you plug any holes inside your estate. Now, combined with SD-WAN, vRNI can help across the entire life cycle of the deployment. So day one, after the migration, we can make sure that the SLAs are met. And then day two, it will actually help with the operation of the network and the troubleshooting. One of the interesting things that I will also mention at the end is that vRNI can also help even before you deploy SD-WAN. So day zero, we have a capability of creating an assessment. So this is where vRNI gets deployed in a traditional network. So looking at a network based on Cisco routers, primarily using MPLS as a transport, and it will sit and talk to up to 20 of those legacy routers. It will gather a lot of information and then come up with a very easy to understand report that can then be presented to higher level execs inside the company. I will show you a sample report at the end of the session, but on a high level, it has an indication of the ROI expected. So you can input things such as the cost of the MPLS versus the cost of the internet, visibility into the traffic patterns. So how much of the traffic is going to the internet, how much is going inside your own organization, what are the top talkers, top applications, etc. And also some recommendations as well. We even go to the length of positioning the right edge for the right branch. Also, I wanted to summarize a few of the points that vRNI brings to the table. For those of you who are still wondering, okay, I have my orchestrator, but why do I need this extra tool? In the end, it does cost something extra in order to deploy. And there are a few big reasons. First of all, the troubleshooting and the visibility is enhanced. And that is even if you're just using vRNI for your SD-WAN estate. If you're already having other products, if you're already running VMware inside the data center, you'll then be able to see traffic from any IP or any VM going anywhere else. Product team even added visibility into gateways. So you know exactly how much and how well the traffic is going out via direct internet access, via gateways, via hubs going towards other edges. So it's really, really a nice way to visualize everything that's going on across your entire estate. Secondly, this idea of trends will actually allow you to start doing some capacity management. And this is something that was not really that easy to do from the VCO itself. vRNI can also help you stay on top of your PCI compliance and make sure that there's nothing wrong there. And with the addition of Nyansa in the next version of VeloCloud Code, you'll then get to understand exactly what's happening in the local area network and even use their amazing self-healing function. So let me give you a quick demo on vRNI, specifically on the relationship with SD-WAN. Now logged into the platform here, I have different things that I can do depending on whatever I'm interested in, micro-segmenting my network and discovering my applications, operate my data center, but I'll just click on the SD-WAN tab. And that brings me to an overview of my entire estate globally. Like I see, I have 7 edges, 2 hubs, and 2 gateways. Really nice that we actually show you the gateways and how they operate. In total, they utilize 13 links, and I have a breakdown between the internal and the internet-bound flows. Also, all in all, I'm using 238 applications. Now we see loads of events here, both critical and warning, and loads of warnings when it comes to the edges and the links themselves. Rest assured that if you want to know more, you can take this generic report and click in any of the elements to find out exactly what happened. So if you see a lot of problems associated to an uplink, you can click the plus button on the side and keep drilling down. The VeloCloud link is not healthy. Which link is that? I can see it's a USB port, a dongle that got disconnected, and also a recommendation. I should go to the VCO and see if the link is now up and running. We can also see that vRNI pulls a lot of information when it comes to the quality of experience. Now going back to the overall view of the state, scrolling down, I can understand that all my edges are under 3.4.3 version of code. I get a full log of events over the last 3 months, and then I can start drilling into the traffic distribution. So what applications are being used, what edges do most of the talking, what edge pairs communicate the most. And if you scroll down, you can actually click show more. So it's not just the top of the application or edges, at vRNI can show you everything. It even gives you the breakdown of the flows when it comes to QoS, the bulk, real-time, and transactional classes, and also where the flows are heading. Are they going directly on the internet? Are they traversing a hub? Are they going through a gateway? Now I can pick any of those elements here and narrow down the report. So for example, I'm looking in the Detroit branch, I can just click on it and that will bring me to a brand new screen. I mean, the report looks the same, but now I can understand what events affect this branch in particular, the uptime of the branch, how healthy the links are, and how many tunnels it currently supports. Going all the way to the right-hand side, we see how many of the policies that we set for quality of service are actually in use and how many not. And if you're wondering why this branch has 6 tunnels, well, this is because we are connected not only to the Hillsborough data center, so it acts as a hub for the Detroit branch, but I'm also connected to 2 different VCGs. And because I have 2 links, this means 2 times 3 equals 6. Now on the left-hand side, you see the network topology, and if you have devices in the LAN that already talk to vRNI, vRNI will then start constructing the topology of the local area network. Scrolling down, you get an idea of the flow distribution, how many flows go directly on the internet, how many go via a gateway, how many go via a hub towards other edges. And again, everything here is clickable. So if I click on the flows for the gateway to understand which parts of my internet traffic could go there, I have full accountability on all of them. Scrolling down, I can then look across all the tunnels that this edge constructs with the hubs, with the gateways, and understand exactly the performance on them. So this is something that you'll start seeing also in the new dashboard of VeloCloud Code 4.0. We can really go in depth here, while we can go inside the metrics, understand how the applications are running across the edge itself. We can take it link by link or tunnel by tunnel. One of the great things about vRNI is that it can be used to alarm you in case something happens. And for this, we need to set up what we call thresholds. So you go inside the thresholds tab, maybe search for something that's already existing. So you'll see that there are a couple of VeloCloud thresholds. This one, for example, states that if the upstream packet loss on a link goes more than 1%, alarm me. As you see the scope here, the threshold itself, and also which edges have generated alerts in the last 3 days. And with the same logic, you can go back and create your own. So you can add an alert, give it a name, give it a scope, let's say I'm looking at all my active and connected edges. And here I can start generating different types of notifications, whatever that's critical, moderate, or just a warning. And I can either send them immediately or as a daily digest to a group of email. Even better, I can get vRNI to send SNMP traps. I can have a problematic site that I just want to keep a closer eye on. I can just say edge equals Detroit and let me know if the uptime exceeds thresholds, deviates from past behavior, etc. So really, really good way to configure the system to reach out to you as opposed to you looking at it. One last thing that I want to show you is the power of vRNI to go across your entire infrastructure. So let's pick up a particular application. So for example, Hive Media. I can click on it to start learning more. What branches generate this sort of traffic, what tunnels they utilize, are there any problems associated to it. But besides this, let's use the system to have the overall view from the end device all the way to the Hive video server. So we'll use this information and we're going to go inside this path tool. We're going to select the source 101, 100, 180. I'm going to select the destination. And when I click submit, the system now runs the query and it will show me the whole end-to-end path. From the end device hitting the local LAN, hitting the edge in Detroit, being tromboned through the Hillsboro data center, then hitting the edge in Washington, being switched through the LAN, a few errors here that we might need to check out in case the application is reported as having issues, and then following the traffic path as it is virtually routed inside the vSphere host all the way to the virtual machine itself. It's a really, really easy way to understand if something goes wrong, what path the data takes, and what devices on that path currently have issues. Now, before I go, I also promised to show you around the VMware pre-SD-WAN assessment. So this is a free tool that you can use on an existing traditional network based on Cisco routers. Maybe you're looking at migrating away, introducing SD-WAN, and are trying to understand any sort of ROI calculations or business recommendations. Well, what you can do is that you can input your details here and we give you a 1 month free trial of vRNI. You then deploy the collector as a VM. You point up to 20 routers to it and you let it there for a few days to sit in, collect the data, and get something meaningful across. And this can also be downloaded as a report. And as we said, this report looks into the savings that you should expect by introducing cheaper internet lines. It also gives you an understanding of the traffic flows, how much of the traffic is headed for the internet, how much of the traffic is local, any issues with your existing routers, for example, any packet draws, any average availability, things that maybe you were not aware that you have issues with. And then in the end, our recommendation when it comes to what edges and what bandwidth tiers you would require for each of those sites. So again, going back to this page, the link is pages.velocloud.vmware.com/vRNI SD-WAN assessment.